Now let's take a look at how you can actually stop a running loop, because that's a very salient concern. You might want to stop something executing, and certainly in the case of task, we've already seen how to do that using cancellation tokens. It is possible to use cancellation tokens here, but there is other functionality as well. So let's take a look at how this goes. I'll actually make a new static function here called demo that we're going to use. So I'll call this function from main demo like so, and let's begin. So essentially, let's first of all just make a parallel for loop. So I'll do a parallel.for going from 0 to 20, and let's suppose that I simply take the value x and I process it somehow. Alright, so here is my loop. I can output the value of x at the current task ID. So let's do that, right line. So I'm going to say that the value of x has the current task dot current ID in square brackets here. So this is nothing special. We can actually execute this and see the result here. So let's run this, and we get, as you can see, there is a total of 4 tasks at the end in square brackets, and we're processing the 20 items. Once again, we cannot expect them to be in any kind of order because it's all concurrent. Okay, so what we're going to do is we're going to discuss the idea of canceling, or indeed interrupting, the execution of this loop. Now, in order to be able to interrupt the loop, and there are different ways of interrupting it, you have to provide yet another argument. So the lambda, the function which takes which parallel for takes, has to change. Instead of taking just the value x, we also take another variable called state. And the type of this variable, as soon as I spell it correctly, the type of this variable is parallel loop state. Let's actually add those types in here. So I'm going to insert the signature, and you can see that here is our integer, which is being cycled from 0 to 19, and here is the parallel loop state. So state is exactly the object which allows you to, for example, cancel the execution of the loop. So here what I can do is I can say if x is equal to 10, then why don't we stop the loop? Now, there are different ways of stopping the loop. First of all, there is just stop. Now, what stop does is basically stops the execution of the loop as soon as possible. As you can imagine, this is not going to happen immediately, which means that other running tasks which have already done some work, they're not going to be stopped. It's only the new tasks which are going to be not happening effectively. So if I execute this, you're going to see that we ran a few, and you'll see that after we output 10, there was some other tasks which were in fact executed. So it's not that you stop immediately on this particular task. You do get to execute some of the other ones as well. So stop is a very direct method. There is another method which is very similar, and that is break. Now, the idea of break is that you kind of make a request to stop the loop execution of basically stopping the execution of iterations which are beyond the current iteration. Because keep in mind that the way this is executed is in iterations, in kind of steps, and you're basically saying that, well, we got to x equals 10, let's stop here and let's try not to do any further iterations beyond this one. So it's a less immediate kind of stop than the proper stop, but these things are very similar. So in addition to that, because this is these are two of the kind of recommended ways of doing that, it's also possible to throw an exception, for example. So if we throw a new exception like so, this exception will actually propagate up to demo, and it will propagate up to main, so we'll basically crash a program if we do this. You can see that there is an unhandled exception here, and we would need to somehow catch it. So let's actually do that. I'll go and select the entire block here. So I'll do like this, and let's actually surround it with a try catch. So I'm going to catch an aggregate exception. That's what you get when you execute a parallel loop this way. However, it's important to note that you won't always get a an aggregate exception. In fact, if you cancel the loop, we'll see it in a moment, you will get an operation canceled exception instead. But let's just handle this. So I'm going to basically just say, let's call it aggregate exception, AE. So I'm going to say AE dot handle, and I'll take the exception and let's actually output it. So I'll write line, for example, e.message, and I will return true. So this is how you would handle an exception that happens in one of the threads in a parallel for execution, for example. So if I run this, I now just get a proper exception readout. So essentially, if I just run this again, you can see that after 10, some threads did execute, but not all of the tasks were processed, meaning not all of the elements. So as soon as you encounter an exception, that basically causes a stop in the overall execution of the parallel loop. And in fact, what you can do is you can take a result of the parallel execution and inspect it for whether the thing was actually completed. So let's take a look at that. The idea here is that let's do I'll put a blank line in here, and then we're going to output whether the result was completed. So here in parallel 4, that actually returns a result, and a result is of type parallel loop result. So let's see if I can introduce a variable here. So I'll just call it result, like so. So we have a parallel loop result type, and you can inspect it. So here, for example, I can find out whether the task was completed successfully. I can say, was the loop completed, and then input the result here. So result is completed tells me whether the result was in fact completed. Now it's also possible to find out if you did a break instead of a stop. You can find out the iteration on which you did a break. So if we did in fact do a break instead of a stop, what you're going to find is you're going to find that result has a value called lowest break iteration. You can see that it's nullable, which means if you didn't do a break, it's going to be null. But if we do a break, then it's not going to be null, and you can check whether it has a value. And if indeed it has a value, let's actually output it. So I can say that the lowest break iteration is, and then result dot lowest break iteration, like so. So essentially, let's actually do a break so that we can see how the whole thing works. So if we do a break, we check whether the loop was completed successfully, and we get a false. And also the lowest break iteration is 10, and this actually corresponds to the iteration on which we called break. Okay, so these are some of the ways of stopping the loop. There is another way, of course, which is with cancellation tokens, because it just so happens that you can provide a cancellation token. We saw that in a previous example. So let's take a look at how that would work. Essentially, you say var cts equals new cancellation token source. Sorry, cancellation token source like this, and then you make a bunch of parallel options. So remember, parallel options, they would be here. Let's actually create a local variable, and what you can do then after initializing is you can say parallel options dot cancellation token equals cts dot token. Okay, so you can do this, and then of course as the loop is executing, you can at each at any state, you can, for example, cancel the token right from here. So from here, I can say cts.cancel, and what this would do is it will once again cancel the loop, but we're in for a surprise, because remember, cancellation throws an operation canceled exception, and you might expect that those exceptions will all be wrapped inside a single aggregate exception. Unfortunately, that is not the case. And if I execute this, we once again have an unhandled exception of type operation handled exception, canceled exception rather. So what this means is that in addition to handling aggregate exception, you also need to catch operation canceled exception if you want to be safely exiting a cancellation. All right, so these are the ways in which you can actually stop a loop.